Okay. So in today's class, we are going to start our new topic, that is routing. First of all, we need to understand what do you mean by routing. Routing is basically made up of word route. What? Route. So routing is something like a process by which we are forwarding our data, our packet from one network to another network. What I written here, please read this one. Routing is the process that enable routers to direct data packet between different network. Yes. For example, this is the router. And I already told you what is the use of router. The use of router is to forward your packet from one network to another network. If you want to forward your packet in the same network, what you need? You need switch. But if you want to forward your packet from one network to another, you need router. So whenever any packet reach onto the router, what router will do? Router will check its which table? Routing table. Right? And on the basis of routing table, router will decide where they needs to forward your packet, and that overall process is called routing. Clear? For example, this is the router, this is switch 1, this is switch 2, and this is switch number 3. And with this switch, for example, PC number 1 is connected, PC number 2 is connected, PC number 3 is connected, PC number 4 is connected, PC number 5 and PC number 6 is connected. For example, here you are using 10.1, 10.2 and 10.10 here on this interface. Definitely on this interface, you will use the different network ID, right? Because I already told you on router, every interface of the router will be in the different network, right? So for example, here I am using 20.1, here 20.1 and here 20.2. Here I am using again 30.10, 30.1 and 30.2. For example, if you want to ping from here to here, what will be the source IP address? Source IP address will be 10.1, destination IP address will be 30.1, packet will reach onto the router. What router will do? Router will check destination IP address is 30.1. Router will check its which table? Routing table. Which table? Routing table. Fine. And for example, that is interface 0 by 0, that is 0 by 1, and that is 0 by 2. And inside the routing table, you will find there is some entry. For example, entry 10.0.0.0/8 directly connected by interface gig 0 by 0. Similarly, 20.0.0.0 directly connected by interface gig 0 by 1. 30.0.0.0 directly connected by gig 0 by 2. Getting my point? So whenever this packet will reach onto the router will check this routing table. And inside the routing table, this router will found you are pinging 30.1. 30.1 means this belongs to which network? 30 network. And 30 network is already present in its routing table. That is entry number 3. See, according to the third entry, what is the interface by which router should forward your packet? That is gig 0 by 2. So whenever this packet will reach onto the router check the destination IP address, that is 30.1, and router will forward your packet by gig 0 by 2. By this interface. Getting my point? And the overall process is called routing. Overall process is called routing. Clear? So routing is something, a process by which router will take the forwarding decision. Router will take the forwarding decision by checking its routing table, and on the basis of routing table, that is called routing. Clear? Now, next is component of routing. Component of routing means whenever any packet will reach onto the router, what are the component router generally check? What are the components router generally check? Clear? And what I told you, whenever any packet will reach onto the router will check which table? Routing table. So definitely these components should present inside the routing table. Getting my point? Yes or no? Right? So, for example, I open this topology. Okay, I open this router. And what are the command to check the routing table? Let me zoom it. See here. Enable, I'm writing the command show IP route. So please remember, this is the command by which you can check the routing table. Clear? So I write here show IP route. So see, when I write this command, when I am writing this command, this is the result I am getting. Clear? So this is something code. This is something code. So this code will help you to understand. This code will help you to understand any particular routes, any particular network ID or any particular information that is present inside the routing table belongs to what? Clear? For example, here C means what? C means here connected. C means connected. It means this network ID that you are getting here, that network ID is directly connected with this router. Directly connected with this router. Getting my point? Yes or no? Clear? So see here, for example, here on this router I run this command. On this router I run this command. So see here, first see 192.168.1.0/24. So that is something network ID. That is what? That is network ID. And that network ID is connected with which interface? 192.168.1.0. That is connected with gig 0 by 0. Where is gig 0 by 0? Where is gig 0 by 0? There is gig 0 by 0. So this on this interface we are running the network ID 192.168.1.0. Clear? Now, here you see L means what? See, L means local. Local means, see here, 192.168.1.1/32. So I already told you, if you remember the subnetting, /32 means that is the specific IP address. That is the specific IP address. Getting my point? So 192.168.1.1/32, I already assigned on which interface? See here, gig 0 by 0. On gig 0 by 0, I assign this IP address. So see now here on gig 0 by 0, I already assign 1 by 1, 192.168.1.1. Getting my point? So C means that is the complete network ID. Clear? And L means what? L means that is locally configured here. Getting my point? So locally I configure this IP address. Clear? Understand? Now here you see one line. So please remember, read this line very carefully. 192.168.1.0/24 is variably subnetted to subnet to mask. What do you mean by this? This is what is the meaning of this line. So please understand, the meaning of this line is whatever the subnet, whatever the network ID you are using is already divided into smaller subnet. Is already divided into a smaller subnet. Getting my point? So basically this is the subnet. This subnet is already divided into different subnet mask. Clear na? Maybe by the help of VLSM or something. Getting my point? For example, here see 192.168.1.0. So what is the network ID? 192.168.1.0. Clear? But see the subnet mask. Here you are using /24 and here you are using /32. So how many subnet masks are there? There are two subnet masks. There are two subnet masks. Getting my point? So that's the reason here you are getting two subnet with two mask. Getting my point? That is the meaning of this line. Clear? Understand? Now, I hope you understand the meaning of C. C means that directly connected here. That is telling us the network ID. And low means locally, what is the IP address you configured on that particular interface. Clear? For example, 192.168.4.0. So here we are using 192.168.4.0. Clear? So on this interface, gig 0 by 2, on this interface, here we are using 192.168.4.0. But locally, locally what we configure on gig 0 by 2. On gig 0 by 2 here, I already told you on the interface, we are not assigning the network ID. We are assigning the IP address, right? So here on this interface, we are assigning 192.168.4.10. On this interface, we assign this one. So that's the reason here L means locally configured. So locally we configure 192.168.4.10/32. Clear? Understand? So this is the difference between C and L. So why I told you components of routing, in components of routing, when you check the routing table, there are multiple things you will see. There are multiple things you will see. The first one, what I told you? First one I told you the code. The first one I told you code. Getting my point? Understand? So that is something code. So you need to understand. So for different routes, for example, if you see any routes and before that route, if you see O, it means you can easily understand this is the route router learned from OSPF routing protocol. OSPF routing protocol. Getting my point? So basically that is the use of code. Clear? Now next thing that you need to remember, that is next hop. What is next hop? So what do you mean by next hop? So I'm just telling you 2-3 points about the next hop so you can understand. This is the term that refers to the next device or router that a data packet must pass through to reach the destination. to reach the destination. This is very important because a router use the next hop to determine how to forward the packet from source to destination. Getting my point? That is called next hop. For example, see here. For example, I'm just giving you best example. See here, this topology. In this topology, for example, this is the PC number one. Here you are using, for example, the IP address 192.168.1.1. This IP address you are using. Clear? And for example, on this laptop, you are using 192.168.3.1. Clear? Here you write the command ping 192.168.3.1. It means you are pinging from here to here. So this PC number one will generate the packet. In this packet, the source IP will be 1.1. Destination IP will be 3.1. Clear? Packet will reach on router. What router will do? Router will check the routing table. What router will do? This router will check the routing table, and this router will try to find, okay, do I have 192.168.3.1 network entry in my routing table? This router will check. So when you check this routing table, see very carefully. In this routing table, are you able to find 192.168.3.0 network? My answer is no, because when you check this routing table, here I am getting 192.168.1.0, 192.168.2.0, and 192.168.4.0. There is no 3.0, right? It means this router don't know where I need to forward the packet. Where I needs to forward the packet. Getting my point? Yes or no? Right? Now, if this router is don't know where I needs to forward the packet, it means you need to provide, or you need to inform this router where this router needs to forward the packet. That is called routing. That is called routing. But try to understand one thing. If this PC wants to ping this PC, packet will reach on this router. Where this router needs to forward the packet? Here or here? Your answer will be, sir, here, right? So this router is called next hop. This router is called next hop for this router, because if this router wants to forward your packet towards this laptop, this router needs to forward your packet towards this router, not this router. So for this router, who is the next hop? For this laptop, that is this one. Getting my point? So next hop means where router needs to forward the packet to reach the destination. If this router wants to reach the destination, this is the destination. So this router should forward your packet towards here. So for this router, who is the next hop? This router will be next hop. And the interface, this interface IP address will be the next hop. For example, here I am using 192.168.2.1. So this IP will be the next hop for this router. Clear? So this is called next hop. Clear? So basically that next hop is also very important. Clear? So if anyone asks you the very basic thing, tell me how exactly the next hop works. How exactly the next hop works. Clear? So basic things you need to tell, sir, this is the router, and whenever any packet reach onto the router, what router will check? First of all, router will check the destination IP address. What? Destination IP address. Clear? After observing after examining the destination IP address, this router will check its routing table. What? Routing table. Why? Because by the help of routing table, this router will choose the best path to reach the destination. Getting my point? Now, in third point, what you need to remember, what this router will do, this router will check where is next hop. It means if I want to forward the packet towards the destination, where I need to forward the packet. If I want to reach the destination, then in this case, where I need to forward the packet. Getting my point? So where means next hop. Where means next hop. Getting my point? So what this router will do? This router will find where is the next hop. Clear? And not only this, for example, in this case, in this case, if this router wants to reach this laptop, this router no. If I want to reach this router, my next hop is 192.168.1.2. This interface IP address. Clear? That is the next hop. But after that, this router must know if I want to forward the packet, if I am forwarding the packet towards the next hop, what will be my exit interface? Getting my point? For example, if this router needs to forward your packet towards the next hop, that is 192.168.1.2. So this router should forward the packet through this interface or through this interface. The answer is this interface. Getting my point? Yes or no? Clear na? So that's the reason I am telling you here in first step, what router will do? Router examine where is the destination IP address. What is the destination IP address? Does destination IP address present in my routing table? Yes or no? Getting my point? So these are the information router will check. And step number 2, router will check the routing table. And in routing table, router will try to find what is the best path to reach the destination. What is the best path to reach the destination? For example, according to the routing table, if router will find, oh, if I want to reach this destination, this is the next stop. This is the next stop. But in the fourth step, this router will choose, if I want to forward the packet towards this next stop, what is the exit interface to forward a packet towards next stop? If I am forwarding the packet towards next stop, then what is my exit interface? Getting my point? What is the exit interface to forward a packet towards the next stop? Getting my point? So basically these are the thing router will check, and that is called next stop. Clear? Now one more thing you need to understand about the next stop. Basically there are two types of next stop. There are two types of next stop. First one is called directly connected. And second one is called indirect. So directly connected means if the destination is in a subnet directly connected to the router, in this case the next hop is the destination device itself. For example, router 1, router 2, PC1, PC2. Now tell me one thing. If you want to ping this, here you are using, for example, 10.1, here you are using 10.10, here you are using 20.1, here you are using 20.2, and here you are using, for example, 30.10, and here you are using 30.1. For example, from this PC you want to ping 20.2. Packet will reach onto the router. This router already know where is 20.2, because on this router 20 network is directly connected here. Getting my point? Understand? So in this case, that for this router, the destination for this router, what is the destination? You want to ping 20.2. So this is the destination for this router, and 20.2 means this IP address belongs to which network? 20 network, and this subnet is directly connected with this router. It means this, your destination is directly connected with this router. Getting my point? Understand? So that is called directly connected next hop. But try to understand, if you want to ping from here to here, packet will reach here. So if you want to ping this PC number 2, so for this router, what is the destination? 30.1. But this router don't know what is the 30.1. So if this router wants to ping this router needs to forward the packet towards router number 2. So this router is the next hop, because 30.1 is not directly connected, that is indirectly connected. Getting my point? Understand? So basically there are two types of next hop. First one is called directly connected. Directly connected means if the destination which you are trying to ping is directly connected subnet on the router. So in this case, next hop device is itself the destination. But if you want to ping from this PC to this PC belongs to different network, 30 network. Clear na? So in this case, this router needs to forward your packet towards this one. Getting my point? So that is called indirectly next hop. Indirect next hop. Clear? Understand? Now, what are the component I told you? The first component I told you,
Codes.
component of routing. So first component we discuss, that is codes. Second components we discuss, routing table. Third component we discuss, that is next hop. Clear? Fourth component, that is also very important, that is called metric. What is metric? Clear? Now, what do you mean by metric? What do you mean by metric? So we need to understand the metric one. Okay. And the fifth component that we need to understand in routing, that is AD. AD means administrative distance. What is administrative distance? Clear? So basically these are the five component that we need to understand in the routing. That is very important in the routing. Clear? So I hope you understand the next hop. Now we discuss the metric. Okay. Now see, metric. Metric means what? Metric means this is a value used by routing protocol to determine the best path to reach the destination. To determine the best path to reach the destination. So this is the first point you need to remember. Point number two, when multiple routes to the same destination exist in the routing table, in this case, then metric help router to decide which route to use. So that is the second point you need to remember about the metric. The third point, the route with the lowest metric is usually considered as the best route. So basically these are the 3 points that we need to remember about the metric. One more point you can remember, H routing protocols calculate the metric differently based on specific criteria. Some of the routing protocol use hop count. Some of the routing protocol use bandwidth. Some of the routing protocol use delay. There are many criteria. On the basis of routing protocol, calculate the metric. Clear? Understand? So, for example, try to understand, this is the router. And with this router, for example, here one more router is connected and one more router is connected. Clear? For example, here you are using 10th network. Here you are using 20 network. Here is, for example, any 8.8.8. Any routes are there. Here also same routes are there. 8.8.8.8 routes are there. Clear? For example, this router share this information with this router, and this router also share this information with this router. It means this router receive 8.8.8.8 Y R1 also and R2 also. Getting my point? So in this case, now this router will confuse. Why? because this router will confuse if in a future, if I want to ping 8.8.8.8, where I need to forward the packet towards R1 or R2. Getting my point? Yes or no? Right now? So in this case, to solve this problem, there is a concept of metric. There is a concept of metric. So what is metric? Metric is just like a value, and this value is basically used by routing protocol to select the best path. Getting my point? To select the best path. Clear? So for this router, there is the same destination 8.8, 8.8. Getting my point? Yes or no? So in this case, metric will help this router. What is the best path? This one or this one? And according to the third point, what I written? I written the lowest metric always prefer. Which one? Lowest metric always prefer. Getting my point? Yes or no? Right? So lowest metric always we prefer. So for example, there are multiple protocol. For example, RIP. RIP is the protocol. RIP use hop count. What RIP use? RIP use hop count as a metric. What? Hop count as a metric. Clear? So if again anyone asks you what do you mean by hop count? So hop count is nothing. Hop count is the number of routers by which your packet will pass to reach the destination. For example, that is the router 1, router 2, router 3, router 4, and here is PC number 2, and here is PC number 1. For example, if you want to ping from here to here, your packet will pass from this router. There are 4 routers are there. So hop count is 4. Getting my point? Yes or no? That is called hop count. And so please remember, in case of RIP, if you are using the RIP use the hop count as a metric. And one more thing you need to remember, lower hop count always prefer. In case of RIP, if you are using RIP, lower hop count will prefer. Clear? What do you mean by lower hop count? For example, this is the router 1, router 2, and here you are using 8.8.8.8. For example, here router 3 and here you are using 8.8.8.8. This router receive 8.8.8 by R3 and this router receive the 8.8.8 by R1. But in this case, hop count is 2 here and here. But in this case, hop count is only 1. So this router will prefer this one, not this one, if you are using the RIP protocol. Clear? Understand? So this is something you need to remember. Understand? Now, for example, you are using the routing protocol OSPF. If you are using the routing protocol OSPF. Clear? So OSPF use cost to calculate the metric. What is? OSPF use cost. Clear? And one more thing. In case of OSPF, router calculate the metric on the basis of cost. That is called cost. And please remember, cost is router calculate the cost on the basis of bandwidth. So please remember, on the basis of bandwidth. Clear? So I will explain you later when I will teach you the OSPF. So right now just understand, router, in case of OSPF, router calculate the cost by using one formula that is called reference bandwidth by link bandwidth. Link bandwidth. Clear? We will discuss these things in a very detailed way. But right now just understand, in case of OSPF routing protocol, router use the metric that is called cost. Clear? And in case of OSPF, router use the cost and use the cost value, and cost value router calculate on the basis of bandwidth. Clear? For example, there is one more routing protocol that is EIGRP. So EIGRP also use the metric. EIGRP also use the metric. Getting my point? But EIGRP use the metric. EIGRP calculate the metric on the basis of bandwidth, on the basis of delay, on the basis of delay. Clear? So EIGRP also use some formula to calculate the metric, but that is not our point. But right now just understand, EIGRP also use the metric, and the EIGRP calculate the metric on the basis of bandwidth and delay. Clear? Understand? There are other routing protocol, for example BGP. BGP use path attributes. So there are multiple path attributes generally BGP use. Getting my point? That is not our point. But so please remember, BGP also use the metric, and that BGP use the path attribute as the metric. Clear? So that is something, guys, metric. Clear? Understand? So metric is also very important concept in routing. Clear? Understand? Yes. Now, next is AD. AD means administrative distance. Administrative distance. Clear? So the first point you need to remember about the AD, this is a measure of trustworthiness. Trustworthiness, or you can say reliability of routing protocol. So basically what is AD? AD is a measure of trustworthiness or reliability of a routing protocol. Or simply you can say, on the basis of AD value, you can decide on which routing protocol you can trust more. Getting my point? So basically that is the use of AD. Clear? So AD is something a value. So please remember, AD is also value. Clear? Understand? Now, one more thing you need to remember about the AD. It is used when router, it is used when router learn about same destination network from multiple routing protocol. That is very important. That from multiple routing protocol. RP means routing protocol. Okay. See the scenario. Router 1, router number 2, router number 3. Here on this router there is a network 8.8.8.8. Here is the network 8.8.8.8. Clear? And on all the router we are using the same routing protocol. For example, OSPF. What we are using? OSPF. Clear? If you are using the same routing protocol on all the router, this router share 8.8.8. information with this router. This router also share 8.8.8.8. with this router. What this router will do? That is the case number 1. That is the case number 1. See the case number 2. In case number 2, again router 1, router number 2, router number 3, 8.8.8.8, 8.8.8.8.8. Clear? Understand? Now, for example, here you are using OSPF, here you are using OSPF, and for example, here you are using RIP. Clear? So this RIP protocol also share 8.8.8.8 information with this router, and this router number 2, where you are using OSPF, is also sharing 8.8.8 information with this router. Clear? That is the case number 2. Here you have a same routing protocol, and here you have a different routing protocol. Understand? Now, what I written here, please read very carefully. AD value is used when router learns about the same destination network from multiple routing protocol. It means point number 2 is telling us case number 2, because this router receive 8.8.8.8 prefix and this network ID from OSPF also and from RIP also. So in this case, what helps this router to choose the best? That is AD value. That is AD value. Clear? Understand? Now, one more thing. Every routing protocol have default AD value. What is? Every routing protocol have default AD value. For example, if you are using the OSPF, OSPF use the AD value 110. Please remember these things. If you are using RIP use the AD value 120. Understand? That is the default AD value. Now, that is the third point. In fourth point, what you need to understand, router always prefer lower AD value. Which one? Lower AD value. Getting my point, everyone? Router always prefer lower AD value. It means this router receive the 8.8.8 information from OSPF whose AD value is how much? 110. And this router receive the 8.8.8 from RIP whose AD value is 120. So obviously this router will prefer OSPF 1, right? Because OSPF AD value is less than RIP. Clear? I hope you understand. Clear now? Point number third. Router always prefer lower AD value. Router always prefer lower AD value. Clear? Now, point number four. Default AD value of some common routing protocol. For example, if you are using OSPF, its AD value is 110. If you are using RIP, its AD value is 120. If you have a directly connected interface, its AD value is 0. If you have a static route, in this case, AD value will be 1. If you are using EIGRP, so basically in case of EIGRP, there are two AD value. One is 90 and second one is 170. 170. If you are using the internal EIGRP, then AD value will be 90. If you are using the external EIGRP, then AD value will be 170. Clear? Understand? So basically, guys, these are the common routing protocol and these are the AD value for these routing protocol. Understand? I hope this is clear to all of you, right? Now, again, if I ask you a very basic question, what is the difference AD versus metric? AD versus metric. See, what I told you, AD tells us among different routing protocol, which routing protocol is more trustworthy, right? It is telling which one is more trustworthy. Understand? But if we discuss metric, in case of metric decide best route or best path within the same routing protocol. Clear? Understand? I told you na case 1 and case 2. So in case of case 1, if you remember, in case of case 1, what I told you, R1, R2, R3, right? Here you are using OSPF, here you are using OSPF. This router share 8.8.8.8. This router also share 8.8.8.8. In this case, this router will decide on the basis of metric because this router is receiving 8.8.8.8 from R1 and R2 and both are in the same routing protocol OSPF. So here, what is the concept we'll use? Here, you will use the metric. But in case number 2, this router receive one route from OSPF and one route from RIP. And here this router is deciding 8.8.8.8 is best. Why? OSPF. Because OSPF AD value is 110 and RIP AD value is 120. Clear? I hope this is clear to all of you. Understand? Now, one more thing that you need to understand. Maybe you guys have question, sir, which comes first, AD or metric? I mean, whenever, try to understand my question. Whenever any routes reach on the router, this router will check AD first or metric first. AD first or metric first? That is the interview question. Understand, everyone? So what is the answer? Router first of all check AD, then metric. So please remember these things. First of all, router will check AD, then metric. Clear? Understand? Now, Next question is, for example, that is the router, that is the router, and whenever any prefix come, any prefix, what this router will do? This router will check the routing table, and on the basis of this routing table, this router will take the forwarding decision. Right? This router will take the forwarding decision. Now, a very important concept. What are the steps this router will follow whenever this router will take the forwarding decision? Try to understand the scenario. This is the very important concept, and that this is the interview question. Whenever any packet will reach on the router, whatever the steps or whatever the things this router will follow or perform to choose the best path or to take the forwarding decision. Clear? So now see, topic is router forwarding decision. So in step number 1, router check longest prefix match. In step number 1, router will check longest prefix match. Now again you guys have confusion. Okay, sir, what do you mean by longest prefix match? Longest prefix match. Okay. Please see, I'm writing 2-3 points about the longest prefix match. This is the rule. This is the rule that ensure that router select the most specific route in the routing table for forwarding the packet. For forwarding the packet. Point number 1. Point number 2, it is based on prefix length basically. What is prefix length? Or maybe you understand subnet mask. Clear? So what do you mean by it? The longer prefix, longer prefix means a smaller subnet basically. A smaller subnet or a smaller network. Okay. The more specific the route. Specific the route. I will clear you this with an example. Don't worry. Clear? Now, the third thing, or understand like this, I'm giving you an example. Try to focus on this example. For example, I'm writing one routing table here. See the very carefully, guys. I'm writing one routing table. In this routing table, for example, there are 3 routes are there. 10.0.0.0/8/8, and for example next hop is 192.168.1.1. Clear? Second route is in the routing table. This is the routing table. So basically these are the entry present in the routing table of the router. Okay. Second one is 10.1.0.0/16/16, and the next hop is 192.168.2.1. Third one is 10.1.1.0, and this is /24, and the next stop is 3.1. Clear? So basically these are the 3 entry present in your routing table. Understand? And for example, you are pinging 10.1. Sorry. For example, you are pinging 10.1.1.100. For example, you are pinging this one. And this is the router routing table. So you ping packet will reach on the router. What router will do? What router will do? Try to focus here. Try to focus here. If you see this one, if you see entry number 1, In entry number 1, what do you mention here? /8. You mention here /8. It means according to the first entry, your first entry is telling here you are covering 10.0.0.0 to 10.255.255.255. These are the range of IP address you are covering by entry number 1. If you check the entry number 2, in entry number 2 you are covering 10.1.0.0 to 10.1.255.255. You are covering this one. And the third entry, according to the third entry, you are covering 10.1.1.0 to 10.1.1.255. This is the thing you are covering here by third entry. But whenever this packet will reach on the router will perform the longest prefix match. What is longest prefix match? What do you mean by longest prefix match? Here, what are the prefix length? Here you are using /8, here you are using /16, and in this entry number 3 you are using /24. So what is the longest one? Longest one is /24. So the most specific prefix is /24. Getting my point? So whenever this packet will reach on the router, this router will choose this path to forward the packet. Which one? This path, not this one and this one. Why? Because on this path has longest prefix match. Clear? I hope this is clear you and you understand. Clear? So guys, that is called longest prefix match. Clear? Understand? For example, see here, one more example I am giving. This is the routing table, and in this routing table, for example, there is information 192.168.0.0/16, 192.168.1.0/24, and 192.168.1.128 and /25. Here, next hop is, for example, 10.1. Here you are using, for example, 10.2, and here you are using next hop 10.3. And for example, you are pinging the network. You are pinging 192.168.1.140. Packet will reach onto the router. What router will do? Router will check the longest prefix match. What is longest prefix match? So according to the longest prefix match, 16, 24, 25, router will choose the longest one, /25, to forward the packet. Understand? I hope this is clear to all of you. So guys, that is something longest prefix match. Clear? So I hope you guys understand. Yes, in some interviewer will try to confuse you. For example, I am writing one routing table. See very carefully. I am routing table 0.0.0.0/0. That is default route. And next hop is, for example, 10.1. I am writing one more 172.16.0.0/12. And here subnet mask is, guys, 12. Okay. And why 10.2? And the next one is 172.16.1.0/24, and y 10.3, that is 16. That is 16, guys. So for example, if you are pinging 172.16.1.50, packet will reach onto the router. What router will do? So if you check this one, this matches any decision. That is the default route. Getting my point? So in this case, you have how many subnet masks? 0. What is 0, 12, and 24? So what is the longest one? 24. So router will choose this one to forward the packet. Clear? So that is something you need to understand. Clear? So maybe interviewer will try to confuse you. So please don't be confused. Clear? So always check the prefix length first. Clear? So whenever you check the longest prefix match, so these are my suggestion. Whenever you check the longest prefix match, the first step, what you need to do, you need to always check prefix length. What is prefix length? Clear? And one more thing, longest prefix match is independent of any protocol. The router checks the prefix length before considering any ADE or metric, anything. Understand? So that is the step number 1. That's the reason I told you, whenever any packet will reach onto the router check the longest prefix match before checking any AD value or metric. So that's the reason I am telling you, longest prefix match is independent. independent of any protocol. There is no link up with any protocol. Clear? Understand? And the third point you need to keep in your mind about the default route. About the default route. Clear na? So basically default route means what? Default route is the list specific route. Understand? And this is used only when no other route matches. Please remember this one. Whenever any routes will not match in your routing table, in this case, lastly, router will check the default route. Clear? So please remember these things whenever you cover the longest prefix match. Clear? So what we are discussing, guys? We are discussing how router take the forwarding decision. So what I told you in step number 1, router check the longest prefix match. In step number 1, router will check the longest prefix match. Clear? And I hope you guys understand. Now, in step number 2, after checking the longest prefix match, if router is not able to decide where I need to forward the packet, then a router will check AD. What is AD? Router will compare AD value, guys. What is AD value? So please remember, if there are multiple routes, if router is receiving the multiple routes with the same longest prefix match, please remember, this is the router. This router is receiving same route. For example, 8.8.8.8, 8.8.8.8, and the longest prefix match from here and here, both are same. What router will do? Router will follow, or router will check the step number 2. In step number 2, what is this? AD. What is AD? And what I told you about the AD? AD works whenever you are using different routing protocol, right? For example, this router receiving 8.8.8 and this one from both different routing protocol. Both different routing protocol. For example, here you are using OSPF, here you are using the RIP. So router will choose the least AD value. What? Router will choose the least or lowest AD value always. Getting my point? So this one will be preferred. So in step number 2, please remember, router will check the AD value to choose the best path. If there are multiple routing protocol, if router is receiving the same routes but with a different routing protocol. Clear? Understand? Now in step number 3, if there are multiple routes, but the problem is on the same routing protocol. For example, here also you are using OSPF, here also you are using OSPF. So this router is receiving the 8.8.8.8 from OSPF, and here also 8.8.8 from OSPF. So it means this router is receiving the same prefix with the same routing protocol OSPF. So in this case, there is no concept of AD, because AD always works only and only whenever you have a different routing protocol. Getting my point? But in this case, what router will do? Router will compare metric. What router will do, guys? Router will compare the metric. Understand? Clear na? So please remember, I already told you which one? Lowest metric always be prefer. Lowest metric always be prefer. Understand? For example, this is the router. This router receive, for example, 8.8.8.8 from OSPF, and the cost for this one is, for example, 20. And this router receive 8.8.8.8 from same routing protocol OSPF, and cost is, for example, 15. Cost is 15. Understand? Getting my point? Now, which one will prefer? Router will prefer this one, because this route has lower cost value. Which one, guys? Lower cost value. Understand? I hope you guys understand. Clear na? So in step number 3, router will compare the which one? Metric. Router will compare the metric. Fine. Now step number 4, when everything will fine, then router will choose the exit interface. What is exit interface? That is very basic. Router 1, router 2, router 3, 8.8.8.8, 8.8.8.8. For example, this router choose this one as the best path. So this is the interface. For example, that is gig 0 by 0 and gig 0 by 1. This router check the routing table, and this router will check. Oh, that is the best one. And what is the interface here? So on this Interface is kicked 0 by 0. So router will choose the exit interface. Exit interface. Getting my point, everyone? Yes or no? Clear na? So that is called, guys, exit interface. Now, and lastly, router forward the packet. So please remember, these are the steps router will perform whenever router needs to forward the packet. Getting my point? So please remember these things. Whenever router needs to forward the packet, router will perform these are the steps. Clear? Understand? Now, this is something, guys, the part of routing. Whenever router will decide where I needs to forward the packet, router will perform these are the steps. Clear? Now, see very carefully in this topology. What I told you, what do you mean by routing? I told you routing means whenever router will receive any packet, router will check the routing table, and on the basis of routing table, router will decide where I needs to forward the packet. For example, if this PC wants to ping this one, packet reach here, this router will check the routing table, and according to this routing table, this router will find, oh, I need to forward this packet here, not here, to communicate with this laptop. Getting my point? So the overall process is called routing. The overall process is called routing. Clear? But now try to understand one scenario. If you remember, in the first class, I explained you, come here on this PC. On every PC, you need to provide the default gateway. I hope everyone know what is default gateway. Default gateway means the exit interface from that network, right? For example, here you are using 192.168.2.0, this network ID you are using. If this PC wants to ping any device that is located into the different network, for example, you are pinging this one, and this laptop belongs to 192.168.3.0 network. It means you are trying to ping from one network to another. So in this case, this PC run the AND operation, and this PC will find, oh, you are pinging 192.168.3.1. That belongs to different network. In this case, I need to forward your packet to my default gateway. I need to forward my packet towards the default gateway. Now, again, what do you mean by default gateway? Default gateway means that is the exit point. If anyone wants to enter inside your network, and if your packet wants to exit from your network, your packet will go on this interface. Agree, everyone? Your packet always go by this interface. If any packets come in this network, they come by this interface. If any packet go with this interface. So this interface will be the default gateway. Please remember. This interface is called default gateway. So whatever the IP address you configure, for example, here I am configuring 192.168.2.10. So that will be the default gateway for all the PCs here. Clear? So that is called default gateway. And whatever the IP address I configured here, 192.168.3.10. So this is the default gateway for all the PCs. Clear? I hope this is clear to all of you. Fine. So for example, here you write ping 192.168.3.1. Packet reach here, guys. What this router will do? This router will check, do I have 192.168.3.0 network in my routing table? In my routing table, this router will check. Because I already told you, router will take the forwarding decision on the basis of routing table. Getting my point? So what this router will do? See, show IP route. Do you have 192.168.3.0 here? Answer is no. We do not have 192.168.3.0 network here. If this router don't know where I needs to forward the packet, then how this router will forward your packet? That is not possible. That is not possible. Getting my point, everyone? Yes or no? Right? For example, I go to the desktop, command prompt, I am writing ping 192.168.3.1. 3.1. Packet switch. Here, see your packet. This router is not forwarding your packet. Your packet comes back. And when you see on this, go to the command prompt, see what is the error you are getting. 192.168.2.10. You are getting reply from your default gateway. Who is 2.10? 2.10 is nothing. 2.10 is your default gateway. Your default gateway is telling the network that you trying to reach, that is 192.168.3.1, is unreachable. Getting my point? So whenever in the real time scenario, whenever you get this type of error, you can easily understand on my default gateway, for this PC, who is the default gateway? This one. On my default gateway, the network which I am trying to ping, that network definitely not present in its routing table. So that's the reason I am getting this error. That's the reason I am getting this error. So please understand whenever you get this type of error. Clear? So destination host unreachable. It means your default gateway don't know where they needs to forward your packet, because 192.168.3.1 that was not there on this routing table, on this on this router routing table. Getting my point? Understand? Now the problem is, if I want to make communication possible, if I want to make communication possible from here to here, what I need to do? You need to perform routing. What you need to do? You need to perform routing. Clear? I hope this is clear to all of you. Clear? Now, but how? How we can perform the routing? Clear? Now, see here. If you want to perform the routing, there are two ways by which you can perform the routing. First one is statically, and second one is dynamically. So there are two ways by which you can perform routing, guys. First one is called statically, and second one is called dynamically. Or statically you can say, or you can say manually. Both are same. First, guys, what do you mean by dynamically? Dynamically means your router, this router will know all the network information, and this router will know all the network information, this network information, and this router know this network information automatically. You do not need to tell this router manually ki, hey, this is the network ID here, and you do not need to tell this router ki, hey, this is the network ID here we are running. No, we do not need to tell the router manually these things. This router will know about all the network automatically. And this is possible because of dynamic routing. This is possible because of dynamic routing. But again, guys, if router will know or router will learn all the network ID automatically, so definitely there will be some protocol, because I already told you in the first class, in the networking, nothing is happening automatically. So please remember, if router is learning the things automatically, definitely there will be a protocol. Yes. So if you want to perform the dynamic routing, there are multiple routing protocol. For example, OSPF. For example, RIP. For example, EIGRP. For example, BGP. So these are the dynamic routing protocol. These are the dynamic routing protocol. If you do not want to configure the destination routes manually on the router, you can configure any routing protocol. Router will automatically learn everything. That is called dynamic routing. Clear? Now, what do you mean by manually? What do you mean by manually? Manually means we need to provide the route manually on the router. We will go on the router and we will provide the routes manually. Clear? But how? So see, there are multiple ways by which you can configure the routes on the router manually. Again, I am telling, there are multiple ways by which you can configure the routes on the router manually. For example, come to this router. Here we are using 192.168.2.0. Clear? Here we are using 192.168.1.0, and here I am using 192.168.3.0. Clear? Now come to this router. This router know only two network, this network and this network, because both networks are directly connected here. Right? This router already know this network and this network, right? Because both network is directly connected. But again, if I ask you, does this router know about this network? Answer is no. This router don't know about this network, and this router don't know about this network. Getting my point? So that's the reason if I'm trying to ping from this PC to this PC, I'm not able to ping, because this router don't know where is 192.168.3.1, and this router don't know where is 192.168.2.1. Right? So if I want to make communication possible, we need to provide 192.168.3.0, this network ID manually here. And on this router, 192.168.2.0 network manually here. If you will not provide, you are not able to communicate. Getting my point, everyone? Now, again, the question is how I will provide these two network ID on this router. So again, I told you there are two ways. First one is manually, second one is dynamically. If you use any routing protocol, for example, OSPF, RIP, EIGRP, then in this case, you do not need to configure it manually. Router will automatically understand, oh, there is 192.168.3.0 and here is 192.168.2.0. But if you are not using the dynamic, you need to provide it manually. But the thing is how? So guys, there are multiple ways. There are multiple ways by which you can provide the routes manually. First one is a standard static route. A standard static route. The first one is a standard static route. Getting my point? I will tell you how we will configure the standard static route. So first thing you need to understand about the standard static route. This is a route to a specific host or complete network. So please remember, specific host or complete network that is manually configured. That is manually configured with next hop IP address, or you can use the exit interface. See here very carefully, everyone. Now, I hope you guys now understand when I'm trying to ping from this PC to this laptop, I'm not able to ping. The reason is on this router don't know about 192.168.3.0 network, right? Now, what I told you, first one I told you standard static route. And according to the standard static route, so 2 or 3 things you need to remember. First one is either you can allow here one host or either you can allow here complete network. So please remember, first thing, understand. Second one, either you can use next hop or either you can use exit interface. So these are the ways by which you can configure the standard static route. Clear? Now see here. I go to this router. I go to the global configuration mode. Guys, first of all, IP address is already configured here. Understand? So there is no need to configure any IP address. Okay. Go to the global configuration mode. I come in the global configuration mode. I am writing the command. Please see very carefully. Command is IP. First of all, check the routing table. Do show IP route. See the very carefully. This router don't know about 192.168.3.0 network, right? My task is we need to provide 3.0 network here on this router. Okay. So what is the command? IP route 192.168.3.0. Clear? After that, you need to write the subnet mask 255.255.255.0. After that, applies the question mark. Clear na? After that, there are two things. Either you can use the exit interface or either you can tell this router the next hop. Clear? Understand everyone? So see here. On this router, if you want to tell the exit interface, then what will be the exit interface? If this router wants to reach here, so the packet should forward by this interface, right? So what is this interface? Gig 0/0. So that will be the exit interface. Getting my point? If you do not want to provide the exit interface, you can provide the next hop. So for this router, what is the next hop? Next hop is this one, right? So this interface IP address will be the next hop if this router wants to reach this one. Again, you guys will think, sir, why this router is not the next hop? Why this router is not the next hop? Bro, where you want to forward, what is your destination? Your destination is this laptop. So if this router wants to forward your packet to this destination, this router should forward your packet here, not here. Getting my point? Understand? Clear? So basically, guys, there are two ways. Either you can provide the exit interface or either you can provide the next hop. Clear? Now, come here. 192.168.3.0, that is the destination network that we need to provide because this router don't know 3.0. Subnet mask, and after that, I am using the next hop. So what is the next hop, guys? 192.168.1.2. 192.168.1.2. I provide this one. 192.168.1.2. Now check the routing table. So IP route. When you check the routing table, are you able to see something? See very carefully. When you check the routing table, Now there is an entry. See here. S. What do you mean by S? S means nothing, guys. S means static. S means static. Static means this is the entry you configure on this router manually. That's the reason here S. Clear? So see this entry, guys. Now this router no 192.168.3.0. 3.0. If this router wants to forward any packets towards 3.0, this router will forward the packet towards 192.168.1.2. This is the meaning of this line. Again, I am telling, if this router will receive any packet, and inside the packet, if destination IP or destination network is 192.168.3.0, this router will check the routing table, and inside the routing table, you already configure this line. And according to this line, whenever this router will receive any packet with this destination, this router will forward your packet towards 192.168.1.2. Where is this one? On this router. Getting my point, everyone? That is the meaning of static route. And what is this? 1 and 0. 1 is telling you the AD value and 0 is telling you the metric. I told you for static routes, AD value is 1, right? So that's the reason AD value is here 1. Please remember this one. Clear, guys? Everyone, I hope you guys understand. Clear? Now see here. I come on this router, command prompt. I am writing this command, ping 3.1. This route, PC forward the packet reach on the router. What this router will do? This router is dropping the packet. This router is dropping the packet. What is the reason? Why this router is dropping the packet? Guys, why this router is dropping the packet? There are many reasons, guys. There are many reasons why router is dropping the packet. Okay, let me tell you one more thing. Come here. Timed out. You are not able to get the result, guys. Time out. Time out. Time out. Yes, in real-time network, we are using the both. And there are multiple scenarios where we configure these routes manually, and there are multiple scenarios where we are using dynamic also. Clear? So in real-time scenario, we are using both one. Clear na? Now, see here, guys. Come here on this router. No. Okay. No. IP route. Static 192.168.1.2. Where is 192.168? 192.168.1.2. 1.2. 192.168 3.0 on R1 CompT IP route 192.168.3.0 255.255.255.0 and next stop will be guys 192.168.1.2 1.1 192.168 1.2 exit come here on this command prompt 3.1 packet reach see this router forward the packet. I hope this is clear to all of you, right? I provide here 192.168 3.0 network here towards this one. So packet reach here, this router check the routing table, and inside the routing table, what I told you. Inside the routing table, what I told you. See here on this router, check the routing table, guys. So IP route. When you check the routing table, you already provide here. But if this router will receive any packet for this network, this router will forward the packet towards 1.2. Where is 1.2? This is 1.2, guys. Here, right? This router forward the packet here. Clear? Now, what this router will do? What this router will do? This router receive this packet. This is the inbound. This is the inbound packet this router receive. In this inbound packet, what is the destination IP address? Destination IP address is 3.1. Destination IP address is 3.1. Getting my point? What this router will do? I told you, na, router will check the routing table. Check the routing table on this router. When you check the routing table on this router, show IP route. See the routing table very carefully. Does this router know about the 192.168.3.1? This network. See here, 192.168.3.0 is already there and directly connected with 0 by 1. Which interface? 0 by 1. Getting my point? Gig 0 by 1. Where is gig 0 by 1? Where is gig 0 by 1? That is the gig 0 by 1. It means this router will forward your packet through this interface. This interface. There is no problem. Getting my point? See here. See, this router forwarded. So this laptop receive your packet. There is no problem. What this router will do? Now this router will generate the ICMP reply packet because this is the ICMP request. When you check now, this is the ICMP 008, 0x08. That is the ICMP request. Now this PC will generate the ICMP reply 0x00. And in this reply packet, what is the source IP address? 3.1. This PC IP address, guys. This PC IP address. That is the source IP address. And destination IP address is 192.168.2.1. Where is 2.1? Where is 2.1? This one. Getting my point? Clear? So this laptop generated the packet reach onto the switch forward the packet towards the router. Now see very carefully. This packet is getting dropped. See here. In this packet, source IP is 192.168.3.1 and destination IP is 2.1. Clear? Now what this router will do? This router again check which table, guys? Routing table. Which table? Routing table. Now see the routing table very carefully. Are you able to find 192.168.2.1 network here? No, we are not able to find. There is 10th network 192.168.1 dot and 192.168.3.0. There is no 192.168.2.0 network. Getting my point? So that's the reason this router don't know where I need to forward the packet. Getting my point? So that's the reason your packet is getting drop here. Your packet is getting drop here. Then what is the solution? Solution is here you provide now 192.168.3.0 network information. Similarly, here you need to provide the same way, guys. This router don't know which network 192.168.2.0. So here I go into the global configuration mode. I am writing IP root 192.168.2.0 255.255.255.0 and then what is the next hop? 192.168.1.1. I provide here, guys. This one. Now see, show IP root. See, now this router no. Now this router no 192.168.2.0. Getting my point, everyone? Yes or no? Clear na? Now see, now try to ping here. Come here on this PC. I am writing 192.168.3.0. Packet, come here. Packet, go to the switch forward to the router. Router check the routing table. Router forward towards the next hop. Next hop is the router number 2. Router number 2 again check the routing table. In the routing table, this router know where is 192.168.3.0. 3.0 is connected with gig 0 by 1. So router is forwarding by gig 0 by 1. Packet reach onto the switch forward to the laptop 1. Laptop 1 receive the ICMP request. Now this laptop 1 will generate the ICMP reply. In the reply, source IP will be, guys, 192.168.3.1 and destination IP will be 192.168.2.1. Packet reach onto the switch forward to the router. Now this packet reach into the router. This router check the routing table and inside the routing table you already provide, right? Statically, if this router will receive any packet with destination network 192.168.2.0, this router needs to forward the packet here. That is the next hop. Clear? So see, this router is forwarding the packet here. Here communication happened. Getting my point, everyone? I hope this is clear to all of you. Clear now, everyone? Yes. Now I am able to ping. We sent 4 packet and we receive 4 packets, 0% loss. Clear? So this is the first way by which we can provide configure the static route. Clear, guys? Everyone? So what I told you, first one I told you, guys, standard static route. Clear? So in this case, I told you there are 2 things. Either you can use the complete network. Here, what I configure, guys? Here we configure IP route. What I configure, guys? IP route 192.168.3.0 255.255.255.0 and next of us 192.168.1.2. So please see very carefully, guys. This is the same command we configure here. This is the same command we configure here. Yes or no? Right? Now see very carefully. Here, after IP root, what I am writing? 192.168.3.0. What is this? This is the single host IP address or complete network. That is the complete network. It means I am allowing complete 192.168.3.0 network here. It means if this PC number one wants to ping this laptop, this one, this one, this one, this PC can ping any laptop here. There is no problem. Because on this router, you allow the complete network. For example, I go to the command prompt. Here I am writing, previously we ping 192.168.3.1. For example, here I am writing ping 3.2. I am writing 192.168.3.2. Am I able to ping? Yes, I am able to ping. There is no problem. I am trying to ping 3.3. 192.168.3.3. See? Yes, I am able to ping. There is no problem. It means I allow the complete network. So that's the reason. If from PC number one, I am able to ping all the PC who is present in the 192.168.3.0 network, guys. Getting my point? So that is called complete network. That is called, I am allowing here complete network. Or you can say that is called network root. That is called, guys, network root. Please remember. Network root. Clear? But again, if I ask you, I want this PC number one can only ping this laptop. This PC number one cannot ping these one. In this case, you need to configure, guys, host root. What you need to do? You need to configure, guys, host root. But how? See, very simple. For example, go to this router. First of all, go to the global configuration mode. First of all, you need to remove this one. Clear? How can you remove? Just write the no and it removed. Now check do show IP root. See, is there any entry statically? No, there is no entry now. Clear? Now see, global configuration mode, IP root. Clear? What I want? I want PC number one can ping only laptop one. PC number one can ping only laptop one on laptop number one. Here you do not need to write. If you are writing 192.168.3.0, it means you are allowing the complete network. But right now I want only allow host. So host is 3.1. I am allowing only laptop one IP. So I'm writing 192.168.3.1. Clear? After that you need to write what? Subnet mask, right? And if you know the subnetting, I already told you, for any particular host, you need to write the /32, not /24, guys. 255, 255, 255 dot 255. Clear? Then what is the next hop? Next hop will be, guys, 192.168.1.2, right? 192.168.1.2. That is the thing. Clear, guys? Everyone, yes or no? 192.168.1.2. Clear? So what this PC will, what this router will do? Whenever this router will receive the packet for laptop one, this router will forward the packet towards router number two. But if this router will receive the packet for different laptop 2, laptop 3, this router will drop the packet here, guys. Clear? Again, same thing you need to provide here, guys. Same you need to provide here also. Clear? Go to the global configuration mode. First of all, what you need to do? You need to remove this one from here. After that, what you need to do? You want to make communication between PC1 to laptop 1, right? So I am writing here IP root. After that, tell me, guys, IP root 192.168.2.1. What is the PC number one IP address? That is 2.1, right? 255, 255, 255, 255. Clear? And then next hop will be, guys, 192.168.1.1, right? 192.168.1.1. Done. Configured. Now, see, I go to the PC number one, command prompt. I am writing ping 192.168.3.1. See, packet reach onto the switch. Router is forwarding the packet to the router 2. Router 2 is forwarding here, and this is forwarding. Maybe this is the R packet, so that's the reason it is broadcasted. Okay. See, guys, communication is happening. There is no problem. Communication is happening. There is no problem. See. I hope this is clear to all of you. Everyone. Clear? Guys, come here. Laptop number on this laptop. See, we sent 4 packet, we receive 100% successful. There is no problem. Clear? But, for example, go to this laptop. Again, I am pinging 3.2. I am pinging 3.2. Packet reach onto the switch forward to the router. See, this packet is getting drop here. This packet is getting drop here. See now, this packet comes back and you will get the error. Same error that I told you that time. What is the error? See here. What is the error? See very carefully. Destination host unreachable. Destination host unreachable. Why? Because on this router, you are not configured the network route. What you configured here? You configured here host route, guys. What you configured here, guys? Host route. And in this host route, you are allowing the communication between PC 1 and laptop 1, guys. You allow the communication only between PC 1 and laptop 1. Getting my point? So that's the reason PC 1 is not able to ping laptop 2, 3, 4. Getting my point? But previously, in the network route, what you did? In network, you allow the communication between 192.168.2.0 and 192.168.3.0. So it means all the PCs, every device who is present in these network can easily communicate. So I hope now you guys understand what is the difference between network route and host route. Clear, guys? Everyone done? And one more thing. For example, I go to this router. I am again writing no. I am removing this one. I am removing this one. Now, instead of writing the next hop, I told you there are two ways by which you can make the communication possible. First one is either you can use the next hop or either you can use the exit interface. For example, same thing I am writing here, IP route this command, and now I am not using here, guys, next hop. I want to use here exit interface. So on this router, what is the exit interface? On this router, what is the exit interface? I told you now this interface, that is, I think gig 0 by 0. I think gig 0 by 0. I am writing gig 0 by 0. Gig 0 by 0. Check here. Show IP route. See here. If you want to reach 192.168.3.1, router will forward your packet by gig 0 by 0. That is one. This one. Getting my point, everyone? I hope this is clear to all of you. Clear? Now come to this router. Conft. I am writing no. I removed it. After that, what you need to do? Same thing, guys. I remove it, and after that, I am removing the exit interface. So instead of next hop, I will write the exit interface, that is gig 0 by 0 here. Done. Now try to ping 3.1. Send the packet. Packet reach here. What this router will do? See, this packet is getting dropped. This packet is getting dropped. Why? Why this packet is getting dropped, guys? See. Maybe there will be a bug in... Yes, but yes. Now I am able to ping. Now I am able to ping. Getting my point? Understand? So guys, this is the way you can configure the exit interface. Clear? So what is the command I configure, guys? See, let me show you the configuration. This one. This is the command I configured here, guys. Clear? So let me write this command so you guys can read it very carefully. See. Clear, guys? So if you want to use the exit interface, you can use this command. If you want to use the next hop, you can use this command. Clear? So guys, that is called standard static route. Clear? So I hope you guys understand the standard static route by using the next hop, by using the exit interface. What do you mean by network route? What do you mean by host route? Clear? I hope you guys understand very carefully. Clear, guys?
It's clear.